started with this what is called as interface, right? So interface is used for so it's a way to specify the contracts. So you can say that whichever class is implementing this interface, it definitely needs to provide the definitions for the methods. So in the interface, you only declare the methods. You say that, for example, in the transporter interface, we had only one method, which is move. Right? So whichever vehicle or implements this interface, it needs to provide its own move method or move definition of the move. So we have seen two examples. One is that of the car, and the other one is that of the bike, right? So for car, you need this drive mechanism. So the way it moves is by driving, right? You drive the car. But the similarity between car and bike or cycle is that both of them move. Right? That's the only similarity that we are interested in, at least. And when it comes to bike, it also moves, but you need to pedal the bike. So the way it moves is, or the mechanism to move it is slightly different. So with the interface, we are not bothered about the implementation. We are just bothered about the functionality. So, and that is the utility of the interface, right? You sort of abstract the underlying details, the implementation details, and you say that you definitely need this functionality. Now, the way to implement that is can be delegated to the individual classes. So one class like car can implement the move method in one way, and another class like bike, it can implement the move method in a different way. So that is about the interface in general, right? And the syntax is pretty straightforward. So when you have to use the keyword called, okay, let me just go back. Yeah. So you have to use the keyword called interface, and uh, this the usual visibility modifier, right? So if it's public, then it's also visible outside to everyone, basically. And if it's private, then only, let's say, if you define it within a class, only that class can see it, right? So, yeah, so this is the visibility modifier part. This is the keyword, then the name of the interface, and within the interface, you only declare the methods. So you don't provide the definition of the methods, which is the actual body of the method. So you only say this is the signature of the method, basically. So the name of the method, the arguments it can take, the return type, and then the visibility modifier. So you end this declaration with a semicolon. So this is the interface, the way you define an interface. And in order to implement it, let's go back to the, yeah. So the way to implement is to use this keyword called implements. So once you implement a interface, you would have to provide the body for all the methods in the interface. So in this case, we have only one method, which is the move. So you need to provide the body for the move or the definition for the move, right? So in the case of the car, we are simply redirecting that to a different method. So we are using drive here. So it will call the drive, and then drive contains all the code to make the car move, for example. So, so you need to use this implements keyword, provide the definition of the method, all the methods in the interface. And the other point that you should remember is to use this, what is called as the annotation, the @ override annotation. So this is again a keyword. We'll be learning more about the override part in the next topic. But what it simply says is when you implement it, something, you need to consider the local implementation and not give preference to the one that was inherited, right? Or the one that was uh, that came into this class through the implements method. So transporter, although it doesn't have a definition of the move, it still has the declaration. Right? So you're saying that the car now gives preference to this move, this particular move, rather than to the move method of transporter.
Sir, if there are two methods in the transporter class, then we in override we specify two methods.
Yes. So if there are two methods, let's say move and break, then you would need to provide a definition for both the methods. And then, yeah, you need to also override them.
Sir, excuse me.
Yes.
Sir, is there any way that we can actually give a default definition to the methods in an interface?
No, no. So in the interface, then the the body should be empty. The body, yeah, that's the definition, right? So the definition should be empty. Um,
Because it might happen that, like, if we are creating too many methods, then it is possible that we might miss some of them.
oh, misimplementing them.
Yeah, I mean,
Oh,
uh,
if you are no, if you miss it, then you will get this error.
so is there no way around this?
So, so let's say you forgot to you implement transporter, but you do not provide the body for the uh, what's it called, the move method, which is part of the transporter. Then you get then you get an error.
Sir, so what's the significance of implementing it if we can create that method directly in that class?
Oh, so we have seen that in this example. Right? So we are trying to generalize it. So, okay, one of the advantages we will see in the next topic, which is polymorphism, right? So you don't have to, uh, you can keep one part of the code same without without any modifications. Let's say in the future you now want to include more vehicles or more means of transportation. So here you have car, bike, but let's say later on you want to have metro train, and then let's say a bike. Sorry, bike is already there. And let's say flight, for example, flight, bus, metro train. These three things, and the way these three move is also slightly different, right? From the ones that we have already seen. So whenever we want to make use of the just the transportation part, we are only interested in the transportation. In the example that we have discussed last time, so there are two people, two racers, Sophia and Dan, and their goal is to go from one place to the other place as fast as possible and win the race. So they don't care about the transportation. So in this case, we are abstracting out the details, right? So we are not saying whether we need to take a car or a bike or a train. So we are just interested in reaching the destination. So in that case, interface helps with the in terms of the abstracting these details. So that is one thing, and the second one is the polymorphism, which we will see in the next topic. And the third is it will also help with the inheritance part, but not really. Okay, but so later on we'll also see talk about the abstract classes. So we get to know a little bit about that as well. So okay, when we talk about this inheritance, we'll get to know about what is called as multiple inheritance. So there again you would have to use these interfaces. Right? So there are a couple of advantages, but for now you can assume. So this is the main advantage, or in the sense that you can abstract these details and talk about the responsibilities at a high level.
Sir,
Did that answer your question?
excuse me, sir.
Yes.
Sir, the override statement, is it just like a comment or does it have some actual functionality?
Okay, so in terms of how it is treated, yes, yeah, it is like a comment. But if you, so in the sense that if you don't have this override, it doesn't matter. But let's say if you override it and then if you override the wrong method. So for example, let's say you have in the transporter, you had move, but with some arguments. Now you are trying to put this override on this particular move, which does not have any arguments. Then in that case, it will complain.
Okay.
So it's actually a safety mechanism to ensure that you are providing the definition to exactly that method which you had in mind, right? Or which you are supposed to provide the definition for. So if you are providing definition for anything else, then yeah, it will complain.
So if we don't use this at the rate override thing,
Hmm.
then what
Yeah.
happens? Then if I define move without any parameters, and in transporter it has parameters, then what happens?
It will be treated as a different method. So the one in a car would be treated as a different method, and then it will complain, saying that you will get this kind of error, saying that now in the transporter you use move with arguments, and there is no definition provided by the car. So you will get a syntax error.
So basically the interface will not be implemented because the method we've defined in this class, it's not the same as the method we've declared in our interface class.
Yes, that's right. Yeah, both, since both are different, it will complain. It will the compiler would say that it was expecting a definition for the, let's say, move method with arguments, but you have now provided definition for a move method without arguments. So these are two, and then it will complain. Yeah, that's right.
Okay, sir. Okay, sir.
Excuse me, sir.
Yes.
So if there is a move method in car with two arguments, let's just say, and there's a definition for it, and there is this move method without arguments, which is implementing the interfaces method, but this override keyword isn't used. So in that case, will it throw an error?
No, no. So if you don't use override, it's still okay, but it's a good practice to use override. That's it. So you are explicitly stating that preference needs to be given to the method that is defined here, rather than the one that is present in the transporter.
Two functions and with the same name move, then the one in one we don't do at override, and in one we do that at override. So the at override one will be treated as the one in transporter, and the one without it would be treated as part of the class car. So what would happen in that case?
So both are exactly same, is it?
Yeah, the
Shahid,
name and the
Samal.
parameters are all the same in that
Oh,
case.
if both are same, then you cannot do that. So there has to be some difference. You cannot have two methods with the same signature in the same class. That itself is an error.
In that case, even override won't help, right?
No, no, override. So it's a basic error. Right? So compiler will first complain that, okay, you are having two methods with the same signature, and so that is the first error. So you would have to remove one of them, or make some changes. So you need to, for example, add arguments to one of them and not have arguments for the other one, and so on.
Right.
So we cannot create a move method in our car class with any number of arguments
You can, you can. So that's what I was saying.
without
So
overriding. Like if
so you
we
can
do not
skip
override,
override. You can, for example,
yeah.
skip override and then have the same definition. So internally it will take it as an override. So, but it's good to explicitly specify that. So, for
And sir,
example,
if
when
the
you look at this implementation, right, you will immediately get to know that drive is a method of the car. But since you have this tag or the annotation, you get to know that move is now a method that was declared in transporter.
okay.
So,
So it
so
will help.
what is
So
this?
even if one thing, sir, even if the move function in the transporter interface contains argument, and we create a move function in our car class which does not contain any argument without overriding. So will it create a new move function in our car class?
Yeah, it will create a new function, and then it will complain that you did not provide the definition for the method declared in transporter.
Okay, sir. Okay. Okay, sir.
So if there are two methods declared in transporter interface, then when we define it in the car class which implements transporter, so do we have to write override for each method definition, or all the methods that come under the this override annotation will
No,
be
no. So
referred to that
it
only?
is specific to each method. So when you say override here, that is specific to just the method that follows it, which is move.
Yeah, so even if we write this drive method below
Hmm.
this move method, so it will be counted as this car classes method only, because
Yes.
override has a scope.
Yeah, yeah, that's right. So override is applicable only to the immediately following method.
Yeah, right. Okay, thanks.
Okay. So so let's move ahead. Okay, so we already discussed this, right? So an override, like I said, so it's just a signal and to the compiler in this case, and we also discussed the other case. Anyone reading your code. So if I go over the code and then if I notice this override, I'll immediately get to know that this was a method that was declared in this interface. And drive, for example, is a method that belongs to car, right? So so this is the definition of move, right? So we are overriding it, and then we are providing the definition of it. Here in this case, it's drive brake followed by drive. And in the racer, so racer there are two racers, right? One is, so there are two people, Sophia and Dan, if you remember from the last lecture, and they are both racing from point A to point B. So now, like we discussed last time, the transportation, the means of transportation does not matter. So the only goal is to reach that destination as soon as possible, right? So in that sense, whether it's a car or a bike, it does not matter. So we use a general term called transportation, use transportation. And now we are passing in transporter. Right? Transporter, now we are saying transport.move. So if it is a car, it will move the car. And if it is a bike, it will move the bike. So this is an example of polymorphism, which we will see in the next topic, right, which we will discuss in a few minutes. We'll be seeing more of this case in the next topic. So, but this is a way to use interface, for example. So earlier there was a question on what is the importance of interface. So apart from providing these contracts, it can be used in this polymorphism. Yeah, but we'll be looking at it shortly.
So if the object of racer class calls the use transportation method,
Hmm.
then what exactly do we need to pass in the function
From
or
the
to the
argument,
method?
okay. Yes, so yeah, that's a good question. So it needs a type called transporter, but in the last class, I mentioned that we cannot create an instance of the interface, right? There cannot be an instance of interface because it doesn't have any body. There are only declarations of the methods. So there's nothing that the interface can do by itself, right? So, but you can pass any instance that implements this interface. So in this case, we have car instance and bike instance. So either of them can be passed in as arguments for this method call. And we'll look at that example in the next set of slides, right? So we'll see how that can be used for polymorphism. But you can pass any instance that implements this transporter interface. So in this case, it's car instance or bike instance. Okay, so the other thing that is possible with interfaces is you can implement multiple interfaces, right? So an example is given here. So let's say you want to make the color also as abstract, right? So you don't care at a high level what the color is, but it's up to the each individual transport or the means of transport to use or to populate the color or provide the definition for the color. So in that case, you can have multiple, implement multiple interfaces. So first is transporter and the other one is colorable. And the list of interfaces will be separated by comma. So an analogy for that is, let's say, I can be part of multiple contracts, right? So implementing an interface is like a contract, and I can be part of multiple contracts. So for one could be the rental agreement, the other one could be the employment contract. So because of these multiple contracts, okay, in terms of the analogy, it's very similar. So you are involved in multiple contracts. Here the class is involved in multiple contracts and it needs to honor all the contracts. Right? So it needs to implement all the methods in transporter and all the methods in colorable. And that is what we see here. So first the move. So move belongs to transporter interface. The definition has been provided. And colorable has two methods which it has declared. So now since car is implementing colorable, it needs to provide the definition for both the methods. So set color and get color as well. Right? Is that clear? Or do you have any questions? Okay, so let's move on. So that's the introduction to interface, right? So interface, it provides the contracts in the form of the methods. So whichever class is implementing that interface should definitely provide the definition. And it also ensures consistency in the sense that you cannot, for example, by default forget to implement one of the methods. So if you are, if you want some methods to be definitely be implemented, then putting them as part of interface is one mechanism, right? And this is the other one. So if some class is implementing interface, then we'll definitely know for sure that it is providing, it is taking care of those responsibilities that we have declared. So in this case, let's say move. So whichever class transporter implements, we would know for sure that it can move. So whether it's a car, bike, or plane, or metro, train, if it implements transporter, then it can move. So we'll know that for sure, right? So that's the other advantage. And the last one is, let's say if more than one class is implementing the interface, then there is a relationship between these classes. And the relationship is the interface itself. So the way they move, for example, or in this case, both of them can move, right? So that's the commonality or the common thing between these two classes. So those are the advantages of interface. So in the next topic, we'll also see one more advantage, which is polymorphism. But are there any questions so far? So this is a short question, right? Quiz kind of question. So let's say you have this public interface, an interface called clickable, and it has declared only one method called click. Now you are given 4 options. So go over them and let me know which one of them is correct. Right? So imagine that these interface has been implemented by 4 different classes, and in each class, this is the definition that it provides.
A.
Sorry, was there a question?
No, I was.
Sir, A is
Can you
correct.
answer A is correct?
Oh, the A. Okay. Yeah, that's right. So in this case, it's A because A has the same signature as the one that is declared in the interface, and it also provides the definition, right? So if you look at B, the signature is different. You have an additional argument, And if you look at C, the name itself is different. So again, the signature is different. And if you look at D, again the signature is different because you have a different return type. Here it's void, so it's not returning anything, but here it's double. So the correct answer is A. So you are right.